Good day, dear colleagues. My name is Vitalii Tron. Today I would like to present the results on parameters evaluation in the process of solid phase pulp sedimentation in technological units of beneficiation plants. In the world practice, the extraction and processing of minerals, geological reserves of ore with a high content of the valuable component are constantly declining. In this regard, mining and metallurgical enterprises are faced with the problem of rational use of ore with high content of useful minerals and development of the technologies that allows efficient processing of low-grade ores. Many efforts are being made to rationally use poor ores to extend the life of developed deposits and achieve acceptable financial results, such as optimizing the cut-off grade of a useful component, mining production schedule optimization, improvement of technologies for enrichment of extracted raw materials. The key task of information support for the effective control of ore grinding classification processes is the operational measurement of its granulometric composition and determination of the degree of grinding required depending on the physical, mechanical, and chemical mineralogical properties of the enriched raw material. A promising direction in the development of methods to solve this problem is using of non-contact and non-destructive testing tools based on ultrasonic, magnetometric, and nuclear physical measurements. There are different mineralogical varieties of ore that enters the beneficiation process. These varieties differs in several characteristics of inclusion of a useful component, fineness of inclusion, which requires various degree of grinding for its complete disclosure. As a maker of the changed quantitative composition of the crushed ore, it is proposed to use the density of particles of the solid phase of the pulp in the process of its deposition directly in the technological units of concentration plants. This parameter is determined based on the result of measuring the attenuation of bulk ultrasonic waves and LAM waves propagating in the iron ore pulp and metal platinum that is contact with it, as well as the level of the pulp in the process tank in which it's located. On the figure, it is shown a typical technological scheme of the process of grinding ore during its enrichment, which is widely used in processing plants. Initial ore and water are supplied to the mill, which operates in a closed cycle with hydrocyclones. Their flow is monitored by the sensors and controlled by a closed local automatic control system based on proportional integral derivative controllers, PID controllers. The ore crushed in the mill is pumped through the mill discharge sump to the cyclone clusters. Hydrocyclone sands are returned to the mill and the overflow through the Rutherford tank is fed further to flotation or magnetic separation technological processes. Here you can see the main notation and variables used in the mathematical model of the sump in the technological chain of the closed Grindin cycle. Q on T denotes the flows at the corresponding point of the technological process. W is the content of the solid phase of the pulp. M on T is the mass of material in the technological units at specific time t. In addition, when modeling of the Grindin cycle, the following designation were adopted. P on X and T is the cumulative yield of solid particles whose size is less than X, and delta X is the fraction of the crushed material, the particle size of which belongs to the size in specific interval. In the table, it is shown the density and grindability for ore types which are mined and processed from one of the deposits of the Kryvyi Rih iron ore basin. Variations of the qualitative properties of enriched raw materials lead to change in the results of grinding, opening of mineral formations. The basic level of model automatic process control system for grinding are local automatic control system of individual process variables. At the same time, the models of regulated objects are approximated by an aperiodic link of the first order with sufficient accuracy for practical problems. Variations of the mineralogical varieties and characteristics of the ore received for enrichment lead to ambiguous result of the operation of the mill, technological sump and hydrocyclones, as well as their models as objects of automatic control. To maintain the degree of grinding in the initial ore necessary for the full disclosure of the useful component, when the parameters change, the amount of additional water supplied to the technological sump is corrected. It is proposed to estimate the changes of this parameter based on the results of determining the density of particles of the solid phase of the pulp during its working settling in technological sumps of the Grindin cycle. Consider the process of movement of the pulp in the technological sump as it's shown on the slide. In accordance with the scheme shown on the slide, according to the method described in the research, two more signals can be formed. S2 based on measurements of the attenuation of Lamb waves propagating in the wall of the technological sump in contact with the pulp, and S1 based on measurement of the amplitude of high-frequency volumetric ultrasonic waves that have traveled a fixed distance in the pulp. In accordance with the scheme shown on the previous slide, according to the method described in the research, two more signals can be formed. As it was mentioned, S2 based on measurements of attenuation of Lamb waves propagating in the wall of the technological sump, and also S1 based on measurement of the amplitude of high-frequency volumetric ultrasonic waves. The resulting expressions relate the content of the control site class of the crushed material with the density of the solid phase of the pulp is presented on the slide. Thus, measuring the value in accordance with the methodology described in the research and the magnitude of the signal S3, you can determine the value T. On this slide, it is shown the results of modeling the mass balance and dynamics of the granulometric composition of the processed ore in a closed gradient cycle. The root mean square discrepancy between the model of the process and experiment was 0.92%. The results of modeling the mass balance and dynamic of granulometric composition are presented on 4 figures. A is the input signal, consumption of additional water in the technological sump. B, the object output, the class content of minus 0.074 nanometers in the hydrocyclone drain in percent. C is the output of the model, the content of the specific class in the hydrocyclone drain, and D, the error signal. The proposed method makes it possible to dynamically correct the parameters of the model of a closed or gradient cycle depending on the quality characteristics of the feedstock and thereby form the conditions for the disclosure of the inclusions of useful component in the product entering the magnetic separation or flotation. The root mean squared discrepancy between the model and experiment was 0.92. The direction of further research should be the approbation of the proposed approach in relation to spiral classifier and concentrators. Thank you very much for your attention.